Hello. All right, students, please confirm if I'm audible and my video is quite visible to you. Hello. Please confirm once. If the screen is visible to you and I'm also audible. All right. All right. So today we shall do some PYQs of determinant and matrices. See, this is also an important chapter in JEE Mains and advanced also. Okay. So see, there is a question. If X, Y, Z are positive, then 1 log y base x log z base x log x base y 1 log z base y log z x base z log y base z and 1 is the value of this determinant. All right. So you may try it once. I give you 1 minute for that. Okay. So before starting that, I would like to give you 1 or 2 properties of determinant. The properties are, say, before determinant, I'll give you a property of log. Log y base z you are having. So log of any number can be resolved into ratio of log of component to the log of base at some common base. That is log y base b upon log z base b. All right. So जो यहाँ पे the component we have here, same component we have here, the base we have here, is component we are having here. And theoretically, we say the ratio of the logarithm of two numbers, your quotient of the logarithm of two numbers, is independent of their common base. So common base is b. This value is independent of b. All right. Now, if you see this question, 1 log y base x log z base x, this can be written as 1 log y upon log x log z upon log x. I hope there is no problem with this. है ना? Base I am keeping same base everywhere. Now log x upon log y 1 log z upon log y. In the third row, it is log x upon log z log y upon log z 1. All right. Now, another property of determinant. Say we have a determinant A, B, C, P, Q, R, X, Y, Z. So there is a determinant D dash also. Say it is K, A, K, B, K, C, P, Q, R, and say L, X, L, Y, L, Z. So the property of determinant states that we can take anything common from any row. Like from first row, you can take K common. All right. From third row, you can take L common. So how it will work? KL will come outside. It is A, B, C, P, Q, R, X, Y, Z. That means if we multiply any determinant by a constant, it will be multiplied to any one of the rows or any one of the columns. Unlike matrices, in matrices, whenever we multiply by something, it gets multiplied everywhere. Am I clear? But determinant, it gets multiplied in any one of the rows or any one of the columns. So now if you realize from the first row, I am writing this element as log x upon log x. I'm writing this element as log y upon log y, which is again 1. I'm writing this element as log z upon log z. Am I clear? Now, from the first row, you take 1 by log x common. So what you are left with? Log x, log y, log z. From the second row, take 1 by log y common. We are left with log x, log y, log z. And third row as it is. Another property that we are aware of, in any determinant, if any two rows are identical, like this row is identical to this row. So in a determinant, when two rows are identical, value of determinant gets 0. Got it? Value of determinants gets 0. So anybody facing any issue in this question? This was a simple question asked in some yesteryears of JEE mains. So anybody having any issue, do let me know or I will proceed further. Yes, anyone? All right, since I do not receive any objection, I will move forward. So this is a question, simple question on product of two determinants, two matrices. All right. So try it once. I give you a couple of minutes and I'm watching your screen also for your answer. Yes. Quickly attempt. Okay. 1 1 0 1 1 2 0 1 1 3 0 1 and so on and so forth. All right. Anybody else? They are looking for inverse of the matrix. So first of all, from the given equation, what you need to do, you have to identify the value of n. All right, I'm ending this poll. Now we have to do it. Three people have answered B option as correct answer. One has said A as a correct answer. Now see this in this kind of question, they are not expecting that you will multiply for a longer way. Definitely, there is some pattern which we have to identify. See, if I first multiply these two matrices, 1 1 0 1, it is to be multiplied by 1 2 0 1. Then what do you get? First row, first column, I'm getting 1. Then first row, second column, I'm getting 3. Then second row, first column, I'm getting 0. And then finally, second row, second column, I'm getting 1. Got it? Am I clear? Just a moment. I think you are not able to see my screen. Wi-Fi just went out. Hello? Is my screen and voice audible to you? Anybody else, please reply. Is my screen and voice audible to you? Is my screen visible? All right. Now, what we will do, this product, we will execute it with this one. So that means it will be 1, 3, 0, 1. Okay, let's do one thing. Let us not write it 3 as of now. I'll write it 1 plus 2. It will be a better clarity. So it will be 1 plus 2 multiplied by 1, 3, 0, 1. Now, what do you get? First row, first column. 1. First row, second column, you get 1 plus 2 plus 3. Second row, first column, you get 0. Second row, second column, you get 1. That means up to which point I am multiplying, I am getting 1 plus 2 plus 3 and so on. That means this entire left hand side will be 1, 0, 1 plus 2 plus 3 up to n minus 1, 1. And this is given to me as 17801. Now, if you compare left hand side and right hand side, you get 1 plus 2 plus 3 up to n minus 1 as 78. This product will be n minus 1 into n upon 2. The summation will be 78. So it is n into n minus 1 as 78 is 156. So it came 156. Now tell me, product of NC, quadratic we can solve manually if I see. Product of any two consecutive integers, that is equals to 156. Anybody? Product of two consecutive integers, that is equals to 156. So that is 12 into 13. So if it is 12 into 13, that means your n is what? 13, because n into n minus 1 is 12 into 13. So n has to be 13. Yes, JNV Yadgiri, any issue? Yes, please, you may reply in chat or you may speak up. So, and we got n as 13. Now they're asking for the inverse of 1, n, 0, 1. That is 1, 13, 0, 1. If it is a matrix P. All right, they're asking for P inverse. P inverse is what? Adjoint of P upon determinant of P. Now in 2 by 2 matrix, adjoint we can directly find, change the diagonal entries. So 1, 1 will remain 1, 1 and change the sign of off diagonal entries. So off diagonal entries will sign change. So it will be minus 13. And it will be 0. All right. And determinant of P is 1. So your answer will be 1 minus 13, 0, 1. Got it? So There are few students who have just joined, so I'm going to repeat it once again. This is 1101, 1201, 1301, and so on up to this. The sum is 17801. All right. So first of all, we multiply these two. After multiplying these two, I realize a pattern 1, 0, 1, and 1 plus 2. Now you multiply these two with 1301. So if you multiply this, you realize a pattern 1, 0, 1, and 1 plus 2 plus 3. All right. So this is the overall product up to when we got. So it is 17801. All right. So 1 plus 2 plus 3 up to n minus 1 is 78. So n into n minus 1 by 2 comes 78. So n comes 13. Got it? Now if n is 13, so P is what? If this is P, then you have to find inverse of P. Inverse of any matrix is what? Adjoint of P upon determinant of P. Adjoint of this matrix is simply this. Determinant of P is 1. So this is your answer. All right. So this was a simple, easy to understand. Now let's go with this question. Let A and B be two invertible matrices of order 3 by 3. If determinant of AB and determinant of AB inverse is 8, then find the determinant of this is equal to. Okay, so now before proceeding this question, let me elaborate few properties about the determinant of a matrix. So few you must be aware of. Determinant of AB will be determinant A, determinant B. Determinant of AB is determinant A, determinant B. Determinant of A is determinant of A transpose. That is determinant of minus, sorry. That's it. Of A inverse is 1 upon determinant of A. Are you aware of that? Determinant inverse is 1 upon determinant of A. And determinant of adjoint A is determinant of A raised to the power n minus 1. Determinant of Ka is k to the power n determinant of A. So these are small properties you have to take care. All right. Now see this question. Okay, one more question. Determinant of AB is determinant A, determinant of B. Now see this question. What they are saying, determinant of A transpose is 8. That means determinant of A, determinant B, determinant of A transpose is 8. Now I know determinant of A transpose is determinant of A. So from there I can say determinant of A square into determinant of B is 8. This is the first property. Now determinant of AB inverse is 8. That is determinant of A, determinant of B inverse is 8. That is determinant of A upon determinant of B is 8. All right. So determinant of A is 8 times determinant of B. Now, if you solve these two, determinant of B. So if I solve this two, say determinant of A square, determinant of B I replace determinant of A upon 8 is equals to 8. So determinant of A cube will remain 8 into 8. That is 4 cube. So determinant of A is 4. Now determinant of A 4. So determinant of B will come 1 by 2. See this once and try to absorb. See quickly. Got it? Now they are asking you for determinant of B A inverse B transpose. That is determinant of B, determinant of A inverse, determinant of B transpose. That is determinant of B square upon determinant of A. So determinant of B square is 1 by 4. Determinant of A is 4. So 1 by 4. Answer is 1 by 16. Got it? So it was a simple question and you can easily absorb it. Got it? Now, okay, before doing this question, let me explain a concept to you also. Next question. See, system of linear equations. System of linear equations in three variables. Say we have three equations, a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equals to d3. All right. Now, about this system, either the system is called consistent or it is called inconsistent. System of linear equation in three variables, either the system is consistent or we call it inconsistent. So whenever we call it consistent, means having at least one solution. Consistent system means having at least one solution. Inconsistent system means no solution. Now, having at least one system, one solution again contains a category, exactly one solution, or at least one solution. Now, later on in 3D, we will realize these are the equation of three planes. So if these are the equation of three planes, either they will have one solution or they will directly have infinite number of solutions. It is not possible that three planes are passing through only two given points. All right. So at least one solution will directly means what? Infinite solutions. So a system of three equations in three variables. System of equation three variables will be either having unique solution, no solution, and or directly infinite. Hello. So system of equations is having exactly one solution, infinite solution, or no solution. Now, for exactly one solution, D should not be 0. Now, what is D? I'm going to tell you in a while. D should not be 0. Now, see, according to this system, D is what? D is the determinant made up of the coefficients of x, y, z. So, A1, B1, C1, A2, B2, C2, and A3, B3, C3. D1 is what? There will be a term D1 also. D1 is what? Remove this first column and substitute these constants small d1, d2, d3. So it is d1, d2, d3, b1, b2, b3, and c1, c2, c3. Similarly, d2 is what? a1, a2, a3, d1, d2, d3, c1, c2, c3. And d3 is what? a1, a2, a3, b1, b2, b3, and d1, d2, d3. And from this method, value of x comes d1 by d, value of y comes d2 by d, and value of z comes d3 by d. This method is what we call Cramer rule. All right. Method is what we call Cramer rule. Now see, if this d is non-zero, we will definitely going to get a solution. So for exactly one solution, d should be non-zero. For infinite solutions, d should be 0 as well as d1, d2, d3 should be 0. All right. And system will be inconsistent if d0 and at least one of d1, d2 or d3 is non-zero. Got it? So system will be inconsistent if d0 and at least one of d1, d2, d3 is non-zero.
Sir.
Yes.
Hey.
Yes, sir. Any doubt? Hello. Yes, anybody was speaking something, please? Well, so this is the case. So for exactly one solution, D should be non-zero. For at least one means directly infinite solutions, D0 as well as D1, D2, D3 all 0. And for no solution means inconsistent system, D0 and at least one of D1, D2, D3 is non-zero. Now in another theory comes, very small theory. There is a solution if solution is 0, 0. If solution is 0, 0, 0. What do we call it? We call it trivial solution. This is nothing new. This is just the name of origin as a solution. We call it trivial solution. All right. Now see this question. Now it will be very easy. If the system of linear equations x plus ky plus 3z, 3x plus ky minus 2z, and 2x plus 4y minus 3z equals to 0 has non-zero solution. If you realize origin is already a solution, yes or no? Tell me in the chat box, origin is a solution or not for this system? Origin is already a solution. Tell me yes or no? If you won't participate, it will be very difficult to carry on. Please reply. Either you switch on your mic or you write the chat box. all the three equations are directly equated to 0, means origin is already a solution. Now they are saying that the system is having non-zero solutions. System is having non-zero solutions means system is having infinite solutions. Yes or no? System is having infinite solutions. What I told you, either there will be one solution or there will directly be infinite solutions. So system is having infinite solutions. So in this case, if you realize D1 equals to D2 equals to D3 is already 0 because small D1, D2, D3 are 0. So all these will directly be 0 because this entire row is 0 or this row is 0 or this row is 0. So D1, D2, D3 are already 0. So for system to have infinite solutions, for system to have infinite solutions, D should also be 0. So D is what? Determinant 1, K, 3, 3, K minus 2, 2, 4 minus 3. Got it? So for system to have infinite solutions, this determinant should be 0. And now you can solve this determinant and you can find the value of K. Got it? You can find the value of K. So if I solve it, what I'm going to get 1 time minus 3K plus 8 minus K times minus 9 plus 4 plus 3 times 12 minus 2K is 0. So it became minus 3K plus 8 plus 5K plus 36 minus 6K equals to 0. So minus 3K minus 6K minus 9K plus 5K. So minus 4K plus 36 and 8. 44 equals to 0. So this implies value of K came 11. Am I clear? Now this value of K is 11. So first equation is X plus 11Y plus 3Z equals to 0. See, I need to find the value of X upon Y into Z upon Y. That is XZ upon Y square. So what I do, I divide it by Y. So X upon Y plus thrice of Z upon Y equals to minus 11. One equation. Now, second equation is 3x plus 11y. 3x plus 11y minus 2z equals to 0. Again, you divide it by y. So, thrice of x upon y minus twice of z upon y is equals to minus 11. So, thrice of x upon y minus twice of z upon y equals to minus 11. From these two equations, solve for x upon y and z upon y and then multiply them and give your answer. All right. You may use first or third equation also. That's completely your call. It does not make any difference. You can use any two equations. Got it? It's a very good question and this concept is very prominent. I can explain it once again in a quick session. System of linear equation in three variables, a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. If I solve these three equations, value of x I get as d1 upon d, value of y is d2 upon d, and value of z is d3 upon d. Where d is what? D is the determinant made with the coefficients of x, y, z. So a1, b1, c1, a2, b2, c2, a3, b3, c3. D1 is the determinant where I substituted this x column by small d1, d2, d3. These ones. Got it? D2 may I substituted small d1, d2, d3 instead of b1, b2, b3. And in D3, I substituted small d1, d2, d3 instead of c1, c2, c3. So value of x is d1 upon d, y is d2 upon d, z is d3 upon d. Now, this system is what we call consistent or inconsistent. Consistent is what we say at least one solution. Inconsistent is what we say no solution. So consistent at least one solution is further having two cases, exactly one solution, at least one solution. Now exactly one solution again having only one case, its d should not be 0. This denominator, this should not be 0. If denominator is non-zero, we are directly going to get unique solution. Now, at least one solution is simply means infinite number of solutions. So infinite number of solutions will occur while d equals to 0 as well as d1, d2, d3 all are 0. And now the system becomes inconsistent, to which we call no solution, where d is 0 and at least one of d1, d2, d3 is non-zero. Where d is 0 and at least one of d1, d2, d3 is non-zero. Now, if the solution is 0, 0, 0, we call it trivial solution. You know what kind of language do they use sometime? System is having non-trivial solutions. Or system, what kind of system it is? A1x plus B1y plus C1z equals to 0. A2x plus B2y plus C2z is 0. And A3x plus B3y plus C3z is 0. So these three zeros suggest that capital D1, capital D2, capital D3 is going to be 0. So what you need to do? You just need to do D0. So system is having, see, trivial solutions are also there. Now they are saying in the question, system is having non-trivial solution. That means system is having infinite number of solutions. So we'll do D equal to 0. This is what I used in this question. All right. Now there is a question. Is 1 alpha 3, 1, 3, 3, 2, 4, 4 is the adjoint of a 3 by 3 matrix A and determinant of A is 4. Find the value of alpha. Do it. I leave you for a couple of minutes. I'm launching a poll also so that you may mark your answers. Yes. Quickly answer. All right. So this time, so many people have answered. Very good. Majority have answered B. Now let us see. Now see, just 2 minutes before I told you a property that determinant of adjoint of A is determinant of A raised to the power n minus 1, where n is the order of the matrix. So in this particular question, what I'm going to use, determinant of adjoint A is determinant of A square, because order is 3. So now minus 1 will become 2. All right. So determinant of adjoint A is determinant of A square. Now P is the adjoint of a matrix A. That means adjoint A is given to you as 1 alpha 3, 1 3 3, 2 4 4. All right. So this is what? This is determinant of A square. Determinant of this is determinant of 1 alpha 3, 1 3 3, 2 4 4. That is determinant of A square. That is 60. Yes or no? So now you just simplify this my determinant. So if I do it, it is 1 time 12 minus 12 0 minus alpha times 4 minus 6 minus 2 plus 3 times 4 minus 6 again minus 2 equals to 16. So it will become 2 alpha equals to 16 and 6 22. So implies your alpha comes 11. Majority have answered Bombay, and that is the correct answer also. So proud of you. Very good. Got it? Now, let A is x110, x belongs to some real number, and A to the power 4 is, A to the power 4 will become what? A to the power 4 will be A11, A12, A21, A22. Yes or no? Now, in the problem, they are saying A is this. And they have given you value of A11. So, if I try to find out A square will be what? x110 into x110. If you multiply both of them, you get x square plus 1, this into this x, this into this x, and this into this 1. All right. If you try to find A to the power 4, that is x square plus 1, x1. X square plus 1, x1. Just a moment, just a moment. I made a silly mistake. This is not this. x1, x1. So it will be x square plus 1, then this into this, x, then this into this, x, and then, okay, corrected. So x square plus 1, x1. Now if you multiply, what do you get? This into this. X square plus 1 whole square plus x square. So x square plus 1 whole square plus x square. Then this into this. That is x into x square plus 1 plus x. Similarly, this into this, x into x square plus 1 plus x. And then it is x square plus 1. All right. Now, this is A11. Yes or no? So if they are saying this is A11, that means x square plus 1 whole square plus x square is given as 109. All right. And now they are asking for A22. And A22 is what? X square plus 1. So using this equation, find the value of x square or x square plus 1 directly, however you can do, and you will get the value of A22. All right, simple question. Nothing much to do. This is what we do later on. This we have already done. Now see, if ABC are sides of a scalene triangle, then the value of this is. See, I'm going to give you 4 determinants which are very important. You prove them later on, but their values I think you should definitely remember. They are very important and very frequently used. So one is 1a, a square, 1b, b square, 1c, c square. Its value is a minus b, b minus c, c minus a. Easy enough? Now it is 1a cube, 1b cube, and 1c cube. Its value is a minus b, b minus c, c minus a into a plus b plus c. You can prove them easily. Next is 1a square a cube, 1b square b cube, 1c square c cube. Its value is a minus b, b minus c, c minus a into ab plus bc plus c. Got it? And the last one is a b c, b c a, and c a b. Its value is minus of a cube plus b cube plus c cube minus 3abc, whose further factors are minus of a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. And further, this can also be written as minus of a plus b plus c. This will be a minus b whole square plus b minus c whole square plus c minus a whole square upon 2. Note all of them, they are very, very, very important and very frequently used. All right. Now in this question, ABC, BCA, CAB, they are directly using the 4th important determinant I told you. So they are saying ABC are the sides of a scalene triangle. Then this value is positive, negative, non-negative, non-positive, what it is. Yes, I give you a couple of minutes. Yes, there's a poll for you. Quickly answer. Well, so many people answered. So see, this is simple. This result is what? This result is minus of a plus b plus c into a minus b whole square plus b minus c whole square plus c minus a whole square, whole divided by 2. Now see, if ABC are the sides of a triangle, definitely a plus b plus c is going to be positive. A minus b whole square, b minus c whole square, c minus a whole square, they are also going to be positive. None of them is going to be 0. Yes, they can be 0 if a equal to b equal to c. But they have already mentioned it's a scalene triangle. It's not an equilateral triangle. So being a scalene triangle means what? A not equal to b not equal to c. That means this value is going to be negative because of this negative sign outside. Rest everything is positive. All right. Now, if you see this question, the value of lambda and mu for which the system of linear equations has infinitely many solutions. This is very heavy variety in JEE. Infinitely many solutions. So infinitely many solutions means what? D0 as well as D10, D20 and D30. So D0 means what? 1, 1, 1, 1, 2, 3, 1, 3 lambda. Solve it. Get a factor, make it 0, you get a value of lambda. Now D10, D20 and then D30. Now find such values of lambda and mu for which all of them get 0. So when all of them get 0, system will be having infinite solutions. Got it? See another question, same type, very popular variety. System of linear equations, x plus y plus z equals to 2, 2x plus 3y plus 2z equal to 5, 2x plus 3y plus a square minus 1z equal to a plus 1. Now is inconsistent. Inconsistent is what? When it is inconsistent, D0 and at least one of D1, D2, D3 is non-zero. Unique solution means what? You just have to make D non-zero. Infinitely many solutions means what? D0 as well as D1, D2, D3 all 0. And an inconsistent again. So same thing you have to do. You will have to figure out all D1, D2, D3 and T. All right. So this is an important concept and I have explained it in full detail. Okay. Here the entire theory portion. So I'll end up this class here. I'll just request your feedback for the class. So please issue that and thank you so much.